Welcome to our Mathematics for Elementary Teacher with activities. So this course is about algebra and numerical expression, and today we're going to be seeing the first part. So let's dive into the theory. A numerical expression is the meaningful string of numbers and operation symbols like plus, negative, multiplication or division, or rising to a power but not equal, and possibly also grouping symbols such as parentheses and brackets. Students begin working with a simple expression such as in the elementary stage grades like 2 plus 3 and 3 times 5, 35 divided by 7. Later they start using more complex expressions such as 3 plus 7 multiplied by 2, 8 multiplied by 120 plus 42, 35 less 5 elevated to the rise of power of 2. So to interpret the meaning of the expression, we must use conventions in order of the operations. For example, which one here you have to do first? So multiplication or addition? So if you don't know the order of the operation, you might be tempted to do the addition first because it's written first, right? But in fact, you have to do the multiplication first. So you have to do 2 times 7 and then add 3. But this is not the correct order. Unless you put this in parentheses, now we can do the additions first, like 3 plus 7, and then multiply by 2 because you put the parentheses. The parentheses change the order of the operations. So the way it's written here, it means the product of 3 plus 7 with 2. Okay? So, but here you have to do the multiplication first. And here you do the addition because of the parentheses. We're going to be seeing how those parentheses, brackets, and the order of the operations later on in these slides here. Because we look for the addition and subtractions last when we use the convention on the order of operations, an expression can be viewed as broken into components. We often call these components terms of the expression. For example, 1000 times 5 plus 20 divided by 4. So this is actually a sum of two terms, and those two terms are 1000 times 5 and 100 divided by 4, because they are separated by this addition here symbol, the addition symbol. To evaluate a numerical expression means to determine the number to which the numerical expression is equal. We call this number the value of an expression. For example, what is the value of 3 plus 7 times 2? We calculate this as 3 plus 7 times 2 is equal to 3 plus 14 because we have to do the multiplication first, and then we do the addition. 14 plus 3, 17. So this is the value of this expression here. For success in algebra, students must learn to see the structure of an expression without first evaluating it. So, and they must learn to use the structure to reason about the value of the expression. For example, we can tell that 1 plus 2 times 3,927 is even or odd without first evaluating the expression. So this is easy because when you multiply by 2, it's become even. When you add 1, it's become odd. So without seeing what will be the number for the evaluating this expression, I can tell you that this is going to be an odd number. So it must be an odd number because 1 is more than a multiple of 2. This is why I just told you here my reasoning, right? So it must be an odd number because 1 is more, because it is 1 more than a multiple of 2. So this is come out for my understanding of the structure, not because I knew what would be the number that is solving this equation here. So students must be must be a very good knowledge to have to understand first without having to evaluating the equation. So see that expression, for example, 3 times, entre parentheses, 7 less 1 plus 84 divided by 2 less 4 times 2 elevated to the rise of third power. It has three terms, which are combined by addition and subtraction. So here addition and here subtraction. So the first term is a product of 3 with 7 less 1. The second here, 3 product, right? Well, the 3 product by 3 by 7 less 1. So the second term is the quotient between 84 divided by 2. 84 divided by 2. And the last term is the product of 4 with 2 elevated to the third power. So you see here three terms. So let's analyze the structure of this expression. Here's the same expression, right? 3 times 7 less 1 plus 84 divided by 2 less 4 times 2 elevated to the raised to the power of 3. So here it is. The first step is parentheses. Here's that has the highest priority. We have to solve what is inside of the parentheses. So here's will be 7 less 1. This is the first one. The second one would be the exponents. So here's one exponent, 2 elevated to the power of 3. And the third one would be the multiplication and division. So now we're going to do the multiplication. One multiplication here, one division here, another multiplication here between 4 and 2 elevated to the rise to the power of 3. And the last step in this case here would be addition and subtraction. So we have an addition here and subtraction here. So we have 1, 2, 3 terms because they are divided by addition and subtraction. So analyze an expression to review its structure. So this is the structure of this whole expression. So when an expression involves fraction, we can sometimes find ways to make evaluating expression easy. For example, 80 divided by 57 times 57 divided by 61. How can we make this easy? We can cross those 57 here. We can cross it. So now it becomes 8 divided by 61. But now a little bit expression a little bit more difficult to do it. How can we make this one here easier? Because we can see no equal numbers, right? In the top, on the bottom, like in the numerator and denominator. So 21 divided by 50 times by 1 divided by 35. Can you see any relationship between those numbers here? Like for example 21 and 35. So I can see they are multiples of 7, right? So you can divide those two numbers here by 7. So let's see how it goes. So in this case, a factor 7 in 35 and a factor 7 in 21 can cancel. For example, if you divide 21 by 7, it's going to be 3. If you divide 35 by 7, it's going to be 5. So you divide it. So it's going to be 3 times 1, the ones is the same here, and 50 times 5, because you divide by 7. So 3 times 1, 3, 50 times 5, 250. But why can we do this? So let's understand why can we do this. So this is the equation here, is a more is in more detail, so I can explain you how can you do this, why this is valid. Okay, so 21 divided by 50 times 1 divided by 35. So here, for example, 21 is equal to 3 times 7, and 1 doesn't change anything because if you multiply by 1, it's keeping the same value. So we're gonna take this off. So just gonna substitute 21 by 3 times 7, and 50 here, so 35 I'm going to substitute by 5 times 7, which would be 35. Now we can cross 7, right? Because 7 divided by 7 is equal 1. When you multiply anything by 1, it doesn't change the value. So we can cross 7, and then we stay with 3 divided by 50 times 5. So we still have the same equation here. So 3 divided by 250, which is the multiplication of 50 times 5. So we arrive here to the same value. This is the explanation because why can you cut the 7 here, right? Or for that matter, cutting 21 and 35 and simplify by 3 and 5. In the next session, we're going to do some activities, some practical thing that we can do to fix the knowledge that we just see here in this theory. So see you there.